Hello, Calc BC students. I'm Mrs. Keating. Here I am, just to give you a face for the voice. This is actually the first video that I'm recording. Ms. Curry asked me, or maybe Ms. Crow did, asked me to go ahead and start from the beginning pretty much. So I'm going to do that, and I may be going too slow for you, or I may be doing too much review for you, and if that's the case, I do apologize. But I'm going to just bring you up to where I think you need to be by the time I get there, which is hopefully very soon. Okay, so we're on page 61 in your packet, and this is the packet that Mr. Lloyd gave you. And we're going to find the area of a surface of revolution. Now, hopefully he told you where the formula comes from, but I'm going to go ahead, just in case, and show you where it comes from. If we're looking at example 1, find the area of the surface of revolution formed by revolving the graph of f of x equals x cubed on the interval 0 to 1 about the x-axis. No calculators, it says. So we'll do this by hand, taking x cubed, which we hopefully know that does something like that on, whoops, it should be actually right at the origin. Looks like my smart board's a little bit off. Okay, so that's 1, and we revolve it about the x-axis. It might look like that. It really is off. Hold on just a second. Let me adjust a little bit. There, closer to that. Okay, we're revolving this thing. It looks kind of like a cone, kind of a curved cone. And if we wanted to find the surface area of this three-dimensional figure, we would want to actually take these, we'd take like a little slice of it, so to speak, and pretend it looks kind of like a cylinder. And so we're looking for the area of this, which, if you're looking for the area of the lateral area only of a cylinder, that's going to be 2 pi RH. Well, the 2 pi part is fine. The radius, let's grab a different color here. The radius starts at the center of revolution, goes out to your function, and that is the function. So your radius equals f of x, or y in this case. And then the height of the cylinder is this part of it right here. Well, if we get smaller and smaller and smaller intervals, then what we're looking at is an integral, and this is the arc length. So what we're doing, start over here, arc length. And that's how we get 2 pi, the integral from a to b of the radius, which is your function, times the arc length. Okay, let's go ahead and start number 1. S is going to be equal to 2 pi. We're integrating with respect to x from 0 to 1. Our radius is x cubed. And then our arc length is 1 plus the derivative of our function, which is 3x squared. And then we square that, dx. All right, next I'm going to go ahead and square it. And I get 2 pi, 0 to 1, x cubed, square root of 1 plus 3 squared is 9, x squared squared is x to the 4th, dx. All right, what I'm going to do next is I'm going to go ahead and use UDU substitution. I hope that this is the way that Mr. Lloyd has taught you. All right, if I choose my u to be 1 plus 9x to the 4th, then my du is going to be 36x cubed dx. And all I'm doing here is taking the derivative of u to get du over dx. Maybe I should write that for you, just in case you haven't seen this. Du over dx, and that's going to be equal to 36x cubed. And then you multiply up that dx to get the result that I just got. Okay, if I do that, then what I'm going to need here, I've got the x cubed out front. I'm going to need a 36, and so I'm going to want to put a 36 here and a 1 over 36 on the outside. So there's my du. My u is under the square root. So I'm going to rewrite this as 2 pi over 36 is going to become pi over 18. And then my integral, because I'm going to use u, the square root of u, which is u to the 1/2 du, I've got to change my limits. My limits were 0 to 1. So what we want to do, and u here, is we want to plug in a 0. 1 plus 9 times 0 to the 4th gives me 1. That goes down here. And then we plug in the 1. So 9 times 1 to the 4th. And that gives me 10. And so I put a 10 up there. All right, now I can integrate it and plug in my limits. I have pi over 18. And we're going to put our bracket here. Increase 1/2 by 1, and we get 3/2. And when we divide by 3/2, we're really multiplying by 2/3. And that is from 1 to 10. All right, I'm going to go ahead and bring the 2/3 out. Let's see, the 2 is going to cancel with the 18. That goes away. This will become 9. So I'm going to make it pi over 27. And then I plug in my 10. Can't take the square root of 10, so I'm going to just leave it as 10 to the 3/2. And then I plug in a 1, take the square root of 1, and that's 1, cube it, and it's still 1. So there's your answer. And that is the surface area of this very interesting cone-like looking thing. All right, let's move on to number 2. It says, find the area of the surface of revolution formed by revolving the graph of f of x equals the square root of x on the interval 1 to 4 about the x-axis. No calculators. Okay. Now we don't need to see this. We understand the formula, so we'll go ahead and start with writing the formula. 2 pi, the integral from 1 to 4. Our function is the radius, so that's going to be the square root of x, and that's times the square root of 1 plus the derivative of the square root of x. Well, that's to the 1/2 power, so we'll bring down the 1/2 and reduce by 1 to get 1/2. Negative 1/2, excuse me. So that's going to be 1/2 x to the negative 1/2 power squared dx. All right, now I'm going to go ahead and square that. So I have 2 pi, the integral from 1 to 4, the square root of x, times the square root of 1 plus, when I square 1/2, I get 1/4. And when I square x to the negative 1/2, I get, because I have to, when I take a power to a power, we multiply those two. So negative 1/2 times 2 is going to give me negative 1. So that means it's on the bottom. So it's going to be, oops, not a 2. That's going to be 1/4, and then 1 over x would be that. Okay, now what? Well, I'm thinking I'm going to take this because these are both under square roots, or excuse me, yes, square roots. I'm going to go ahead and take this, and I'm going to distribute that x to each of these, and it's going to cancel this x down here. So all under one square root. Okay, x times 1 is x, plus x times 1 over 4x is 1/4. Now this makes it a lot simpler underneath the radical. So I think I'm going to go ahead and start my u du substitution. And I'm going to use u as x plus 1/4. So that means my du is going to be 1 dx. So now we have 2 pi. I need new limits. So if we plug in a 1, my new a is going to be, let's see, 1 would be 4/4 plus 1/4 to get a common denominator, which is 5/4. So I'll put 5/4 on the bottom. And then, let's see, 4 would be 16/4 plus 1/4, which is 17/4. Okay, and then it's going to be the square root of u. So I'm going to write that as u to the 1/2 power du. All right, now we integrate. 2 pi. U to the 1/2, we're going to increase it by 1 to make it u to the 3/2. Divide by 3/2, and we're really multiplying by its reciprocal 2/3. And that's from 5/4 to 17/4. Okay, now this kind of becomes a pain because we're not allowed to use a calculator. So we've got to deal with cubing and square rooting and combining things and not get anything wrong. So I'm going to bring the 2/3 out front as 4/3 pi. And then I'm going to take this one step at a time. 17/4 to the 3/2. And the reason I am doing that is because I don't want to make any mistakes. When we skip steps, I know it takes longer, but we tend to make mistakes. And then what's the point in doing it at all? Okay, so we still have 4 pi over 3 out front. And then we have, let's see, the square root. I think I'll go ahead and leave it as the square root of 17. Square root of 4 is 2. And then I'll just have the whole thing cubed. Minus the square root of 5 over the square root of 4 is 2. And now I'm going to cube that. All right, so we've got 4 pi over 3. Now, if we cube the square root of 17, let's take a sidebar over here. That's going to be the square root of 17 times the square root of 17 times the square root of 17. And these two become 17, and then we have one square root still left. So this is actually going to be equal to 17 square root of 17 over, let's see, 2 cubed is going to be 8. And then I'm going to do the same thing with the 5, so it'll be 5, the square root of 5, over 8. Then I'm going to factor out that 1/8. And it's going to end up right down on the bottom with the 3. So if I factor out, let's see, 4 pi, bringing the 8 out, 3 times 8 is 24. And now I have 17 square root of 17 minus 5 square root of 5. And then one last thing that I want to do is simplify the 4 over 24. And that's going to become pi over 6. And then leave everything else alone. there's our surface area. I tell you what, I'll set this one up for you. And then I hope that you have all the work already done in your packet. And so I'm not going to work this one out, but I just want to explain to you why we set it up the way that we set it up. We want to find the surface area of a sphere. So we start out with our 2 pi. Now, the radius of the sphere is r. And because it is revolving, we're actually going to go from negative r to r. And then we're going to use the function, square root of, if we were to solve for y, by the way, y equals plus or minus the square root of r squared minus x squared. So that's our function that goes under here. And we don't worry about the plus or minus. It's just r squared minus x squared. And then our arc length is going to be 1 plus, now the derivative of this thing. We're going to be using the chain rule. Well, not yet. Let's go ahead and write it as r squared minus x squared to the 1/2 power. The derivative is going to be, bring that 1/2 down, leave the inside, oh, I need more room, hold on. Okay, bring the 1/2 down, r squared minus x squared, because we leave the inside alone, reduced by 1, and then take the derivative of the inside. Well, r is just a constant, so that's 0. So I'm going to have negative 2x. That's my derivative. All right, now I want to clean this up a bit. 2 is on the bottom because this is to the negative 1/2 power. That will be on the bottom as well. And the negative 2x will be on top in the numerator. So we've got negative 2x over 1/2 becomes 2. And then we've got the square root of r squared minus x squared. The 2's are going to cancel, so my derivative is negative x over the square root of r squared minus x squared. Okay, so we plug that in. And then we square it, dx. Okay, so what we're really doing, again, this, when you solve for y, you get the top and the bottom half. That is centered about the origin. So here's our circle. Let's see. Let's go out. We'll say this is negative r, and that's r. This goes up to r, and it goes down to negative r. There's our circle. But we want to take just half of it and rotate it about the x-axis. So we integrate from negative r to r. Here's our function as our radius, and then the arc length. It's over there. All right, one more. I want to show you on the calculator how to use this. How to use it, that is. Let's see, we're going to take the surface area of 2 pi, the integral from, let's see, it's the surface area of one arch of sine, y equals sine x, as it is rotated about the x-axis. Okay, so let's think about this. Sine starts at 0, and it ends at 0. We're going to rotate that, so that's going to be rotated from 0 to pi. So those are our limits. And then our function is our radius. And then the square root of 1 plus the derivative of sine is cosine. We square it, and dx. All right, now we grab the calculator. And let's see. Mine's a little big here. Hold on just a second. All right, so what we want to do is we want to hit Math, and then you want to either go up or down, but it's below 7 here. Let me see how far down. There it is, number 9. We want an integer. If you hit Enter, hopefully this is the screen you get. If it is not the screen that you get, then we need to update your operating system. Okay. So next we want to put in our limits, 0. Oops, I hit Enter. Let's hold on. Clear. Okay, one more time. Math, 9, and then 0. And notice that it gives you a right arrow, so what I should have hit was the right arrow. And then pi, second, pi, right arrow. And then I'm going to enter in my function. So I'm going to hit sine, x, close parentheses, and then I'm going to hit second square root 1 plus, and then I'm going to put in parentheses cosine x, close parentheses, close them one more time around cosine, square it. And then go to the right, and to the right. Okay, dx. So there's my x. And hopefully I didn't type anything incorrectly. And that is not what I have because I forgot to multiply it by the 2 pi. Okay, so let's hit times 2 second pi. There we go. Okay, 14.4. And generally with AP we want 3 digits, so 424, and we don't have any units. Okay, well I hope this helps. Please let Ms. Curry know if you need the newest operating system. I'm happy to help you get that on your calculator because it makes everything look so nice, and you don't have to fool around with the syntax and the context of the problem and stuff like that with your calculator. Also, if you want to see this problem, example 3, finished, if you want me to work it out completely, please let her know. And I hope this wasn't a waste of your time. I hope it helped. And I can't wait to see you. Bye, guys.